get started. Thank you very much for coming today to the CSI Inland Empire chapter. This is our normal November lecture. We have with us Paul Phillips, who is a CSI CDT with his company Design 7. He's an independent consultant for a variety of roofing companies, and he's going to be talking with us today on his systems, which are liquid applied roofing and waterproofing. We asked for some special information on how to do those penetrations and technical issues around ducts and piping and things on low slope roofing. And I've asked him to give us a little extra time on that one as well. Before we start though, however, I want to take one more minute to say we're going to be closed or quiet in December. We're not going to be open for any lectures. Usually most people are not available anyway, but we are starting back up with 2021. And we've got Marcia Falk, who's coming from Rehow, on January 14th. That's the second Thursday in 2021, January 14th. She's talking about design and interior millwork, how that impacts occupant health and satisfaction. So it's not just VOCs. We're not talking about just VOC issues there. We're talking about how color and sound impacts your use of the space. We're talking of things like you find in LEED or in WELL or in the CHIPS program, where you're looking at how to improve your use of a space and enjoyment of a space, besides the smell, the organic compounds, but also the visual and how we hear, the acoustics, etc. So I hope you'll be able to come back with us. It's a free lecture on the same channel, and it will be on January 14th with Marcia Falk of Rehow. So without ado, I'm going to let Paul take it away and start his lecture.
Thank you very much, Dave, and thanks, Connie, for hosting this meeting. Good evening, everyone. My name is Paul Phillips. I'm the owner of a company called Design 7. My colleague Rob Males is also online at the same time, but we represent a number of different roofing and waterproofing manufacturers, primarily single-ply and liquid roofing, but also below-grade waterproofing. That gives me an opportunity to take a presentation which is basically founded by one manufacturer and actually give you a different viewpoint than probably the manufacturer intended. So hopefully I have a more balanced viewpoint than most presenters, and I'll get going. Please don't hesitate to, in the chat, put up any questions that you have, and Connie has promised me he will relate those to me. So liquid applied roofing, this is a SIK 501 AIA approved presentation and qualifies for CES points. And today we're basically going to be speaking about liquid applied roofing membranes. We're not going to go into any depth in below grade waterproofing. We have another presentation that we'd be very happy to provide for you that focuses on that topic. So let's get going. So liquid applied membranes, where are we using them? Well, they are all around us. So foundation waterproofing, sewage tanks, roofing, of course, ponds and bridges. Liquid waterproofing is employed in all of these areas. The simplest method to understand the application, some of them are just a restoration, and they're applied over an existing roof, and they'll do something very, very basic, like just improve the reflectivity and reduce the energy consumption of the building. Also, when it's a restoration, it actually reduces the surface temperature of the roofing membrane, and in that way it can actually prolong the life of that existing roofing that you have. There's a lot of different chemistries. I'll be going into that in more detail, but the most frequent assembly is that there is an acceptable substrate, there's a primer, and then there is a liquid applied to that, which provides a lasting waterproof barrier, and that can be reinforced or unreinforced. And then we deal with things like, from that lower image there, of the lamps. So why would you use a liquid applied system? Most importantly, you're going to use it because it's so versatile. If you look at this building here, which is a tower in Cleveland, this tower was pretty much falling apart. The bottom of those pillars there is actually a gutter that was all rusted out. This was completely restored. And the beauty of applying this liquid applied waterproofing on this masonry, it prevents any freeze-thaw damage into the vertical masonry. It provides waterproofing in the horizontal. And we've even got one building where it was used to restrain masonry from falling out of a very high building. It has other features, such as the fact that it's seamless. If you were trying to cover something of this shape without a liquid option, you would really struggle to do this in a membrane. And then there's a term here called self-flashing. Self-flashing is something that's very important and is really very much the case that it's the characteristic of the higher end, the high quality liquid systems, not the roof recoating systems. And what self-flashing means, or self-terminating, they're one and the same thing, is what they actually mean is that you can take a wall flashing up a vertical surface and you can stop it. And you don't have to put a counter flashing over it. You can just stop. And the water won't go in where that membrane is because it is so tight to the substrate, it prevents water from getting down behind it. If you had a roof membrane, which is the vast majority of roofing, you would always have to have a counter flashing, which is cut into the masonry to actually shed water over the front of the flashing, the membrane flashing. It's fast and easy application, but that again depends on a building like this. It wasn't very fast and it wasn't very easy, but it is possible to do it very fast and very easy with spray applied. There's zero flames involved in its application and zero heat involved in its application. The other thing is, we're talking very broadly here, but there is proven technology in liquid applied roofing and waterproofing that spans over 30 years. And that, again, varies according to vendor and according to system. But some systems have a real-life track record in excess of 30 years. So we're not guessing, we're not making up assumptions in a lab. We know exactly how long this will last. So going on a little bit further, why liquid? Well, we've mentioned its conformability, but also it's probably worthwhile realizing that all roofing membranes are liquid at some time. Bitumen is a liquid, it's oxidized and it's added to reinforcements to turn it into the built-up roofing that we know so well. And then single plies are liquid applied typically onto a carrier, onto a reinforcement. And we're doing very much the same thing. We're applying a liquid onto a reinforcement to give you the waterproofing membrane. Now, there are pluses and minuses for both of those. The beauty of the factory manufactured sheet is that the thicknesses and the quality control is absolutely on the money. This is engineered inside a building in a controlled environment. When you're taking that process and you're taking it onto a roof, it's very important to make sure that the mix ratios are correct, that the guys installing it are skilled, because you're now, and the weather conditions are conducive, because you're now taking that chemistry exercise into the open. Your benefit, of course, is the fact that it will conform and do a number of other things for you. This is a great example. This is a local project in Los Angeles. This is the Ford building on 7th and Santa Fe Avenue. It's an historic building. It was refurbished recently and really quite an impressive building inside, and Warner Music are now the tenants there. On the top of this parapet, we had a difficult situation. It's a terracotta cast hollow parapet cap. It's historic. We're not allowed to move it. We can't attach into it. It's hollow terracotta. So liquid solution was the only answer that we had, and thankfully we had one that works very well. If you look at the top of that parapet, you'll see it's very uniform. It's a nice, clean, even white color. If you look at the bottom of those parapet supports, the angle iron supports, you'll see that you've got a very dark black colored material around the base of those. And that's exactly a good example of taking the chemistry into the field. The upper coating is a single component applied coating, very easy to get it right. The lower part is a PMMA, which I represent PMMAs. I'm not critical of them. It has a number of benefits, but one of its disadvantages is that it has an extremely short pot life, as you can tell by the brush in the top image on the left-hand side, which was left buried in it after only 20 minutes. So it kicks off very, very quickly. The problem with it kicking off so quickly and the chemistry being performed outside of a factory is the guys that are installing it try not to add too much of the catalyst because they want to extend the pot life. And what happens, and what happened here, is they didn't put anywhere near enough catalyst in the PMMA, and the PMMA never cured. It had to be scraped off and replaced. So that gives you an idea of the differences in the chemistry. Other things which are great is its conformability. So for instance, on these steps, we have self-terminating membrane attached to the walls. The plaster comes over it. The risers, the treads, very easy to detail in a liquid. Also in the top surface of that liquid, we can cast a sand, so we can introduce slip resistance into that as well. That would be impossible to do with a membrane. Other things, you can detail this with a membrane, but the busier it gets, the more your roof will favor a liquid solution, a liquid approach to waterproofing it. This is not a particularly busy roof, but there is a cost and an ease of detailing ratio that we have to bear in mind. A big wide open roof, it would be too expensive to install it with liquid. A very small, heavily detailed roof would actually be cheaper to install it with liquid and would be more comprehensively waterproof. So why not a membrane? Well, the reason not a membrane, or one of the reasons not a membrane, is the fact it has a lot of laps. And roofs always fail at the lap or around the edges. So you can actually avoid all of that potential by putting a liquid in, and you now have removed all of the laps off the roof. Depending upon the liquid, there's a vast array of liquids and quite a difference in performance. Some are literally just a reflective coating. Some cannot stand the slightest amount of standing water. Some can stand a little bit of standing water, and some are completely impervious to standing water. So that's something to bear in mind as well. The other advantage you have with a liquid is if you apply a membrane over a concrete substrate, as in this diagram here, the membrane, even if it's adhered, won't actually stop water tracking around underneath it. So if there was a penetration, it's going to track under the membrane and it's going to come in at the first crack in the concrete. So that's the disadvantage of a membrane. If you apply a liquid to that same substrate, it wouldn't matter if the concrete cracked, because the penetration would have to line up perfectly with the crack for it to come in. And even if that did happen, from underside of that slab, it would be very easy to tell where that water went in and get onto the top of the roof and fix it. Now, this is an important thing, especially for things like equipment platforms that have one heck of a lot of detail. They have a heck of a lot of penetrations down into them, and people are bolting into them after the waterproofing is put on. This is an ideal example of why you should use a liquid on an equipment platform. Having said that, if you are now putting that same liquid, whatever it may be, over insulation and cover boards, you've now got another layer where water can track. So this advantage is lost once you add insulation into the mix. Other things here, this is a beautifully detailed single ply roof curb that's been detailed here, for example. It doesn't get better than that as far as detailing is concerned. But with a liquid, it's simplified. It's much easier to make sure there are no capillaries in that detail with a liquid. Then we get on to horror stories like this one. If you've been in roofing as long as I have, you see hundreds of these where someone's had a problem, they've had a leak, and they've done something creative to stop the leak, and then they've done something more creative onto their creation to stop the leak, and you've got 15 layers of garbage, and none of them are keeping the water out. If you look at that detail on the left, man, I wouldn't recommend it, but just the fact you can do it shows you the versatility of a liquid roof membrane. Again, this is a very common detail, and on an asphalt roof, it's very standard and really not a problem most of the time. If it's installed correctly, the workmanship is good, then you won't have a problem with it. But if we look at that image in the background, the vertical flashing has not been properly adhered. That's no good. That's going to fail. If you look in the foreground, you have a pitch pocket, number 7. I absolutely loathe pitch pockets, and will do everything I can to prevent them going into your design if I'm given a choice. The option with liquid, of course, we've now avoided all of those potential weaknesses. So that's a great advantage of liquid. And like I say, pitch pockets versus no pitch pocket, there's only one answer, and it's no pitch pocket. Let's do something else. There are so many better options now that this shouldn't really be seen in new roofing. Method of application. Like we've mentioned already, it goes around complex details very easily. If you look at that centered picture there, we've just stopped it on the masonry. There is no continuation, there's no counter flashing, it can just be stopped. That's a big advantage. Also, we're avoiding flame, but I don't think, I mean, this slide is really set to scare you of torch applied roofing systems. Most of the time, they're no problem whatsoever if the applicators are skilled, if the project is put together right, if we're going onto the right substrates with the right flashing details, it won't be a problem. But during application, they generate smoke, and particularly hot asphalt, hot applied systems generate a lot of smoke. So if that's within a school campus, you might not want it. The torch applied, ironically, is less smoky because it smokes for a very short period of time, and you haven't got a pot that's cooking away all day. Other application methods for liquids, we can apply it with a roller, we can apply it with a spray, and of course sprays come with other complications. Every positive has a negative. So you could end up painting a few cars you didn't intend to paint. You have to be very careful about the weather conditions when you're spray applying. But if you have a very large complex shape like this metal roof, it can be ideal. Other methods, there are saturators on the market where the material is applied into a saturator. The reinforcement is actually dragged through the liquid and coated with the liquid before the reinforcement is applied. It's kind of a reworking of very old technology. This used to be done with bitumen, but now it's being done with some very high-tech liquid applications. And then the image on the right is a polyurea application. Now that's a lot of equipment to put this down right. The beauty of polyurea is it's very robust. It goes down very quickly, and it cures out very quickly. You can spray it on and pretty much walk straight over it. The downside is it's a two-component nozzle mixed system that has to be applied in a heated line. So you end up with a lot of protective gear, and you end up with a lot of equipment costs to be able to apply it. Two types of reinforcements are available for liquid applied systems. They generally boil down to two. One is polyester and one is fiberglass. And the advantage of fiberglass is it's very conformable. When you look at some details that I'll show you later, you'll see how the fiberglass folds and bends and the fibers separate and it forms the shape that it needs to form. Polyester, you have to cut, you have to shape. It doesn't stretch so much, so you have to cut fingers into pipe surrounds and stuff like this. But the advantage of polyester is that you can go what they call wet on wet. So you put your base layer of resin down, you put your polyester into it, you back roll it to suck the resin through the polyester, and then you put your top coat straight on. So it can be in certain circumstances faster. Polyester also has the disadvantage of having those visible seams. Now they're not seams in the same way as an asphalt roof is a seam. It is still a monolithic substrate, but you probably wouldn't want to look at that on a balcony if it was your balcony finish. So coming back to what do you get with the liquid? You can get everything from a solar reflective California Title 24 compliant surface, which is also, if it was acrylic, for instance, is inherently fire resistant. You can then apply a silicone, which would give you the same unreinforced performance, but there are other complications with silicones. Silicones can be very useful. They pick up dirt like crazy. They won't stay white for very long. If you want to re-roof it, you more or less have to take the silicone off to re-roof it. You can't overlay it. The beauty of something that's simple like an acrylic coating, it can be just a solar reflective coating. It can be reinforced with polyester to give you a greater longevity. You can even get a 20-year warranty for an acrylic coating, but it is a material and labor, limited material and labor warranty. It's not what we call a no-dollar limit warranty, so it's a limited warranty. But the beauty of an acrylic is you can add another layer, you can add another reinforcement, and you can just keep going. The disadvantage of both silicones and acrylics is they can't take any standing water. So if you're re-roofing over an old roof, you're probably doing it because you've got puddles on that roof. If you put an acrylic into a puddle, it won't last very long and it will come away and debond. Silicones do a little bit better, but not a lot better. Here's a great example of an acrylic roof. That's IKEA in Burbank. I'm sure we've all shopped there at some time. We've all suffered that. That's the old one before they opened the new one. That got a restorative coating over an asphalt roof with a company called Western Colloid's acrylic coating. Other things you get with liquids, it can be pretty versatile on substrates. So some are not too versatile, some are, but the best of them can go over wood, over metal flashing, over masonry, over concrete, and they are limited to only two things that they can't go over. One is coal tar pitch, because that has a lot of volatile elements like creosote within it that attack just about everything that's applied over it. So you can't go over a coal tar pitch, an old coal tar pitch roof with the liquid, and you can't go onto Kynar finished aluminum or steel. Kynar is a very close relative of Teflon, and as you can imagine, it's designed to prevent anything bonding to it, including a roof coating. So there's the material applied. I believe this was getting a wood deck. It's a small balcony getting a wood deck over it. As you can see, some other substrates, everything from asbestos cement that we don't see too often now to an EPDM, a failed EPDM single ply roof. It'll go over an asphalt roof, over metal roofing. Here's the detail being put together. As you can see, this is a roof drain. I should add that the red that you're looking at is the primer that's been used down onto the existing roof substrate, and the white is our new roof going over the primer. You can see from this final image here that the material conforms beautifully down into that drain bowl. No need for a clamping ring, no need for sealant. This is waterproof for as long as the roof will last. Now, as far as longevity is concerned, you'll probably get about 10, depends on the roof, about 10 to 15 years out of an acrylic, about the same out of a silicone. You might get a little bit longer out of a silicone roof if it's well installed. And then you get onto the urethanes and the PMMAs. They'll both give you a life of around 30 years and a warranty up to 25 years, and that's a no dollar limit warranty. So one we kind of refer to in the trade as coatings, the other we refer to as liquid roofing. And the liquid roofing gives you a much longer performance, a much longer warranty. It'll tolerate standing water. It's a very high performance roof membrane. It has an associated cost with that, which is over twice the cost of a roof coating. So you have to understand what you're purchasing to decide whether or not you need it and whether or not it's of value to you. This is why I talk about roofing and don't install it. I would rather not walk on this substrate over this big drop, but gives you an idea. Difficult to access places, high-rise buildings, areas where kicking out a roll of roof membrane would make the job particularly difficult. Anything with any density of detailing, it starts to tip the balance in favor of a liquid roof instead of a membrane roof. This is an example of a building in New York. It's a high-rise. The last thing anyone wants to do with this building is tear it off. So they prepared the substrate and reapplied a liquid roof over the top of it. So whatever came off this roof could go down in the elevator. The liquid system that came onto the roof came in 5-gallon pails. That can go in the elevator, and the roof can be installed without the crane. Okay, now for the chemistry. It's pretty simple. With any kind of coating or any kind of paint, you've got two different types. You've got non-reactive and reactive systems. A non-reactive system is something that cools down to cure or dries out to cure. Or maybe it has a solvent which flashes off for it to cure. So the material is carried with water, for instance, with acrylic. The water dries out and it leaves the acrylic coating on the substrate, which would also give you an idea of why it can't take ponding water, because that chemistry starts to reverse. In a reactive system, you've got component A and component B. And some of these component A's and component B's are actually two chemistries coming together, mixed together and reacting and setting up on your roof. So polyurea is two-component. Polyurethanes, the type that would be used in a traffic coating, are two-component. And PMMA, polymethyl methacrylate, is its chemical term. It's an extremely high-performance material, and it's two-component. The upside of PMMA is that it goes off extremely quickly. So it's used, or a version of it is used for restaurant kitchen floors. They close the restaurant at midnight, they empty the kitchen, they hit it with an MMA, it's called. They hit it with a brand new MMA floor, shot blast it, put a brand new MMA floor, get out of the building, they're opening for breakfast. That's the beauty of MMAs or PMMAs, super fast. When you're roofing, again, that can be an advantage if you have an access area that you want to get waterproof very quickly. But honestly, most of the time, it tends to be a little bit of a disadvantage in the fact that the guys installing it have a very, very short time to get it installed. And that very short time, when you've got a 5-gallon pail of mixed material, can be as small as in Los Angeles with the temperatures we have, as small as 20 minutes. And when you've got $700, 5 gallons of $700, and 20 minutes to get it out the bucket and get it on your roof, it can compromise your detailing. It can compromise your mixing. You might mix it a little bit lean, as I showed before, or you might leave $200 sitting in the bucket that you can't use. So that is one of the disadvantages of that, but it does have advantages. The single component reactive types are silicones and moisture cured and moisture triggered polyurethanes. So they're actually going on the roof as a single component, but they're reacting with something in the environment to cure them. And most of the time that's moisture. When it cures with moisture triggered as opposed to moisture cured, there's two different things. A moisture triggered takes a tiny piece of the moisture in the atmosphere and it creates a chain reaction. So it just kicks the reaction off and the reaction happens within the material. Moisture cured will actually continue to absorb moisture throughout the curing process until it's fully cured, and then it won't absorb any more moisture. So what does that mean to you? What does that mean? Why is that important? The reason it's important is that if you're in Florida, or if you're in Los Angeles at this time of year, if your material is going to be open to the environment and wet for a period of time, you want it to be something that isn't affected by that fog rolling in off the ocean or that little light shower that we have in the middle of the night. This is what it looks like in real life. On the left is moisture cured, and on the right is moisture triggered. And this project on the right is in Florida. The heavens opened after the material was laid, and as you can see, the big raindrops have actually put dents into the material. They haven't actually reacted with the material at all. When this is demonstrated, and we do some demonstrations, we literally open a bottle of water and we tip it on the wet membrane as soon as it's put down to show you that it bleeds and runs off. Moisture cured, things like traffic coatings, if they get that shower of rain or that dampness in them, they will start to froth like a Coca-Cola when you open it too fast. And they'll actually react with that moisture and it will damage the surface. So on the left, what you'd have to do the following day when it's dried out is you'd have to take an abrasive and get rid of all that damaged substrate and then apply another coat. On the right-hand side, you don't actually have to do anything, but if you wanted to, you could just wipe it clean and apply another coat. So if we're now comparing the two in a little bit more detail, the PMMA tends to be about 15% more expensive than the moisture triggered. They both have a very good track record. PMMAs have been around for fewer years, so there's only a 15-year track record with those, but there's nothing to indicate that they're failing. We believe that they're going to last as long as the moisture-triggered urethanes. But there you see you have 20 minutes cure to get foot traffic on it, whereas really you're coming back the following day with the moisture-triggered to apply another coat. So the labor could be slightly impacted by the fact you've got an extra day on site if it's just a small area. But honestly, with the offset of the wastage and the potential for error, I don't normally see that these moisture triggers ever cost more than the PMMAs to install. So if you're looking to recover a roof, this is really where liquid roofing comes into its own, because you have a situation where you can look at a roof, and in California we're only allowed 2 roofs. So I'll come out, or my colleague Rob will come out, and we'll do a core cut into that roof. And if the bad news is to the owner, you've got 2 roofs, you've got 2 choices. You have to put a roof restoration on it, or you have to tear it off, because you can't put a 3rd roof over to overlay. And that can be quite an expensive event. If you imagine a large roof, the current cost of removing a roof is actually greater than $1 a square foot right now. So that's an expensive operation, tearing off roofing. With a roof restoration, you can avoid that. You can overlay it, You can leave everything in place. You can leave tapered insulation in place, which is an expensive item, to keep your drainage lines running, and you don't add any height. So you're not adding any insulation height. California Title 24 has re-roofing as one stage, and then it has remodeling as the second stage. And if you remodel, you now have to comply with the insulation requirements. So this can sometimes for a client be a very big dollar decision, whether you overlay what's there or whether you tear it off and start again. If you do tear it off to start again, then typically you're going to go back, and it would really vary according to deck type, but we would either mechanically fasten a barrier board down, or if it was plywood, it could go directly to plywood, but you wouldn't get a fire rating with you going directly over plywood. So we tend to always put in a cover board, or we go to concrete. It varies so much, it's not something that I can really give you any real guidance on now, but if you have a project and you're considering this, that's what my company does. We'll give you that advice. So disposal costs are not realized when you're overlaying. This particular example was for Disney in Florida, and they decided they had paving on the other side of this building that had these colors, and they wanted these colors on their roof. And it was primarily for people flying over the Disney resort. They wanted to see that. So that gives us an idea of how much money Disney has. So, okay. So we would always, before we recover a roof, we take things very, very seriously. We would always inspect that roof and look for any moisture in that roof assembly. One thing we simply will not do is put a coating over a roof that has moisture within it. And that can sometimes just be clearing an area 10 feet around a drain, putting in new insulation, a new base layer, and then putting the coating over the top. So we have those choices. The assembly doesn't have to be a plywood deck. Can be concrete, can be metal deck with a substrate board. We typically, now this is, I apologize, it's a national group of slides. In California, it's unusual that we would put a vapor barrier in over a plywood deck. We're more likely to put a vapor barrier in over a concrete deck where we're concerned about moisture within the concrete coming up through the roofing system. Then we would apply insulation. That would either be adhered or screwed down in place. Then we would apply a cover board or even another base sheet that can go down. Then we would apply resin, reinforcement, and resin. And that's our finished system. So this example here, this is quite an unusual example because of the insulation is very specialist. I don't know if anyone is aware that there is now an insulation available for roofing called R50, and it is only 1.5 inches thick, and it produces an R50 insulation value, which is absolutely tremendous. A typical 5.5 inch or 6 inch thickness of the other insulations will give you R30. This will actually give you R50 in 1.5 inches, and it has a corresponding price tag, but sometimes, like this project, that price tag is small in comparison to changing the structure of the building, opening up doorways, and putting in an awful lot of other works in order to allow for the increase in thickness of insulation between what was originally installed and the new roof. So the insulation is going down over, in this case, going down over a vapor barrier and over some polyurethane insulation adhesive. That's a 2-component adhesive. It nozzle mixes, it goes on like honey, and then it starts to rise, it starts to foam, and we put the insulation into it. Then over the top of that, we put a cover board. There's the cover board. In this case, they put another base sheet over, and then they applied the liquid roofing system over the top. This was an expensive solution for this roof, but it was actually the cheapest solution for this roof because this was a very tall building. There would be a significant amount of work that would have to be done to allow for the increased insulation thickness, and this was the most economical solution. So design considerations. Do you want to re-roof or do you want to overlay? You're tearing off. You have to consider the cost of removing the roof. And this is a great example. You don't think these things exist, but they do. Someone has a penthouse out onto this roof, and they've just put a load of concrete pavers down on this roof, probably not designed to take the weight. and a lot of heavy pots and plants over the top of that. So probably not designed to do that either. And then when it comes to re-roofing, they want you to re-roof the building but not move anything. So we've had that situation, and a self-terminating liquid can actually get us by in that situation. So we need to bear in mind the cost of removal, the cost of access, any need to reinstate or upgrade what's there, and sometimes liquids can find a solution which avoids those costs. Here's some examples. We have this precast concrete building here at State Farm Center in Illinois. That's it being applied. It was applied with rollers, but the majority of it was spray applied. And this is our high performance system with a 20-year warranty. This is a great example. Frank Lloyd Wright made some beautiful buildings, but he also made some buildings that weren't great at keeping water out of them. And this is one of them. If you look at the top right, you can see that the concrete needed a significant amount of repair. We built up areas that were low to increase the water flow where required. And that was all done. That's the beauty of one vendor that I represent. They manufacture all of those components. So not just the waterproofing, they manufacture the sloping materials, the concrete repair materials, the sealants, everything that's involved is provided by one manufacturer. And the advantage of that is, of course, there's no finger pointing. You know, your sealant debonded from my roof coating is not a conversation that ever happens because it's one company. And I think that's a gorgeous color that they've done it in. And that was an extremely large concrete building. That's the Meriton Civic Center. On a similar note, we have the Golden Rondell Theater, again, Frank Lloyd Wright, and we manufactured a custom gold-colored application material to go over the top of this and re-waterproof it. And then we're down to more simple buildings with sloping profile roofing. We actually did one of these roofs for one of your members, George. Thank you, George. We applied a silicone because it provided the right price point. It provided a very high performance, long-lasting roof over a metal roof to keep it going. Then directly over concrete, Wrigley Field. We've taken the seats are all taken out. The whole thing is re-waterproofed. There's slip-resistant areas for people to walk on. The seats go back in. We've got a waterproofing system there that will last for 30 years. That's significant. And then simple things that can also be added to liquid applied roofing. For instance, we can add a flake and a clear coat over the top of it so you can make it very attractive. If you had balconies or small areas that you wanted to do that, that's something that's within the bounds of liquid roofing. This is more typical. A couple of planters, a concrete deck with some very low skylights in there, so the flashing heights are very low. Planters are constantly wet. You need something that can follow the planter shape, encapsulate the walls, cope with the pavers sitting on top of it, the constant wetness under that growing media, and then the skylights themselves have actually, pardon me, they've actually been roofed in there. They're actually completely enclosed, and I guess the amount of light wasn't worth the amount of leaking in that particular case. Okay, that has ended my first part of my presentation. Connie, where are we on time? I'm going to proceed with my my second part of the presentation. I'm not actually seeing anybody or hearing anything. I hope you're all still there.
Yeah, we are still here. Connie, I think, is on mute, but I think we're at about 30 minutes right now.
Okay, so that might be a good time to wrap up part one, Connie. I clicked on the chat and I can't click out of it, so I've probably stopped it there, and I'll restart. Part of my presentation. Connie, I don't know if you can help me share my screen again, please. Great, thank you. Let me just open this up. Go to applications.
Hold on, guys. A little technical problem, but no problem. We'll catch up here.
Okay.
Paul, can you hear me? You're muted, Paul.
Technology, when it works, it's great, and when it doesn't, it doesn't. But we're getting there. Hold on just a minute, guys.
Okay, I'm back. Sorry about that. It was a screen hidden under another screen when I set up, when I hit play on my PowerPoint, it hid this screen. So let me see if it will start the slideshow again, which it has. Now let me see if I can share that without muting myself. Yes, there it is. Sorry about that, everyone. Can you see that?
Yeah, it's feasible now.
Great. The people who are muted are giving me the thumbs up. That's good. Okay, now focusing on roof detailing. I've already touched on this particular project, and it's a great example of the difficulties sometimes that you encounter with roof detailing. We had a reinforcement beam, a steel beam, C-channel, halfway down this parapet. We had the cap that we could not drill into. And then we had a large single-ply roof as the main roof area. And that's done basically because that was the most economic thing to do. But when we hit this corner, we hit this problem. And the liquid roofing solution was absolutely perfect. Matches the guarantee. It can actually lap over the single ply, both manufactured by the same vendor. So that gets rid of any of our potential warranty issues or conflict issues there. So that's the finished roof. And again, we didn't have to go down the front face because this was a listed building. We weren't allowed to go down the front face. But because of its self-terminating characteristics, we didn't have to go down the front face. This is how an internal corner is dealt with a liquid. It's a kind of a very small scale asphalt roofing detail. If anyone's familiar with asphalt roofing details, you tend to have a cant on the inside corners. So that will actually, still happen with a liquid roof, but that cant is only 3/4 of an inch. It's very, very small, and it's formed with sealant. This is a great detail. It's kind of funny. I was working with an architect, and he suggested this detail, and I immediately stole it. And several months later, I visited that architect, and I put his detail on the table in front of him and recommended it. So it goes to show. But I love this detail because what we've done here is we put a liquid roofing solution over a plywood equipment platform. And the problem always occurs where you penetrate the waterproofing. Well, if you can install something like this, you get the sound reduction of that concrete topping. You also end up with something you can fasten into that you don't have to penetrate the roofing or the waterproofing at all. And with a two-component metal flashing around the outside, you can replace that roof as many times as you wish without needing to touch that waterproofing over the platform. Also, this is a project that I've worked on recently. Again, a listed building, a very large listed building. It was the Century Plaza Hotel in Century City. It had a pretty poor sheet metal flashing on the outside edge. It's big curved sheet metal flashing, but it was listed and we weren't allowed to move it. So it was actually removed. We put the single ply roof in, and then we finished it with the liquid, and we took the liquid onto the old flashing. So it can get you out of jail, liquid roofing. This is an overlap. What we have in this example is we have an existing roof that we're trying to overlay with a new roof. This is a wide open, very large roof, and we don't have enough money in the budget to re-roof or over-roof the entire thing. So what happens here is the single ply membrane is taken to a point across the roof. It's terminated with a termination bar, and then it's tied in with the liquid roofing. The liquid roofing is compatible with both the single ply and the existing asphalt. So you now have a 20-year warranty on a 12-inch wide strip going across the roof, which probably won't ever see the 20 years. It will probably be, the rest of the roof will probably be re-roofed within 5 or 10 years. But we're not relying on sealant. This is a do it and forget it detail. It needs to be re-roofed before the asphalt roof fails, but that's it. And that's the solution that we just didn't have 10 years ago. This is an outside corner in liquid roofing. They tend to be double reinforced, but we'll advise you if you're interested in this system or similar systems, we'll advise you as to the actual specifics for the system that you're installing. But most frequently, the liquid itself is reinforced, and before it's installed, the local areas are reinforced. Again, these kind of details would be really difficult with a membrane roof. What we have on the left-hand side of this detail, if you can see it, gladly you're probably on your own computers and you can get close to the screen. But if you look at what we have on the left-hand side is a thin set and tile, which is being applied directly to the liquid waterproofing. So the liquid waterproofing in this case is installed. It has sand cast into the top surface. That sand is then is allowed to cure and dry. That's swept off, and then a thin set material and tile can be applied directly to it, or a thick set, or a split slab. There are those options. And then where it steps down, where it meets the rest of the paving on this project, you're coming out of a threshold, you're walking across this 6-foot wide area before you step onto the pavers, which ended up going around a pool. And then we can step down, same system, slightly different chemistry, and we've got a waterproofing system for underneath the pavers. This is my favorite. I'm recommending liquid roofing for every concrete equipment platform currently. It's compatible with any kind of roofing that you might have around it because of the separation of a counterflashing. But this, because of its ability to prevent water tracking underneath it, is a major advance over the traditional take your roofing over the pad, put a metal cover on the pad. You can get rid of the metal cover, you don't need it. This is very robust over concrete. You can apply it directly and apply the equipment directly to it. You can then come back and actually flash something like that angle I'm showing there. You could flash that in again with the liquid. So you can take any maintenance concerns away. Touching on a manufacturer, the beauty of this vendor, Sika, is the fact that they make both roofing systems. So it can go from one system onto the other system with a lap, and the warranty is intact for the roof. If you start to mix manufacturers, you'll find nobody wants to take responsibility for that lap. Other common details, and these details are the ones that I send to most people because I have the same question or the same issue on most roofing projects. On the top right-hand corner, what you're looking at there is Thermoclad, which is a PVC clad sheet metal. We provide it in an 8x4 or a 10x4 sheet to the roofer. They bend it to the shape that the client wants, and it's applied. It is then welded to the roof membrane. It's 100% watertight without any maintenance requirement whatsoever. Fantastically functional. But as you can tell, not every architect's first choice when it comes to aesthetics. If you look below, the other advantage, pardon me, of that material is you don't have to worry about parapet height. You don't need 8 inches above the finished roof for your parapet because the waterproofing is continuous. It goes up and over the parapet and terminates on the outside edge. You can do that with another finish. You can do that with a snap-on fascia. And again, you are not required to put in 8 inches of flashing height in order to do that. But you can introduce a Kynar finish with a very neat mitered corners, spill outs, and a full range of other items. This is the situation I get on most new construction projects. This is a chilled water pipe that's insulated. And if you can see that tiny little detail on there, I'm going to blow up the correct detail. The proposal was to waterproof outside that jacketing. So just to turn up the membrane onto that jacketing, and if you ask the mechanical guys, they'll tell you that jacketing is waterproof. Well, I can assure you it is not waterproof. Worse than that, the warm, moist air that gets into it will condense on that chilled pipe, and that liquid water will run down inside that jacket and right into your roof if you don't get the roof to the main chilled pipe. Now, there are limits. There are temperature limits for roofing systems, and we have to observe those. But in most cases, if it's chilled water, we don't have any issue whatsoever taking a roof membrane directly to that pipe. We have a fight with the mechanical guys on every project because they repeat that you cannot break that insulation. You simply cannot break that insulation. And I totally understand what they're saying, but we're not truly breaking it. We have a tiny little gap in that insulation. And I think that's a small price to pay to avoid water coming into your building. I'm not sure you can really understand what I've sketched here, but this is the common thing. On a roof, you'll have maybe a 12-inch flashing on one side, and it'll step down because of door thresholds or clerestory windows to a 4-inch flashing on the other side. And what we often see and what we don't recommend is that the 12-inch will just step down abruptly to the 4-inch. Then you have to seal the side of that 12-inch flashing to stop water getting in at that point. It actually is extremely simple, if the aesthetics of the building will allow, to simply turn that membrane 45 degrees and take it down at a slope. We then keep the counterflashing continuous. The counterflashing just steps down with the membrane. So maybe aesthetically not beautiful, but from a practicality point of view, no sealant, no vertical seam that needs maintenance or attention. This is just a continuous flashing. Going on to this detail, this is construction specialties or something similar. I see this detail on every roof where there's an expansion joint. The advantage of this detail is it looks neat. The disadvantage of this detail is there's a multitude of disadvantages. One, the detail looks great. It's waterproof. But what happens at the end of this piece, I don't know if you can see my cursor, but this piece of metal is not continuous. So you end up with a joint in that piece of material, which requires maintenance, and the maintenance is unlikely to happen. So you also have a connection between a roofing system and a joint by two different manufacturers, so there's potential issues there. But don't fear, there is an EPDM membrane suspended below this joint to catch any moisture that might make it through. The downside with this is that it's great, it'll stop the moisture, but what do you do with that water? What typically happens with that water is there is a small bore drain pipe, flexible drain pipe, that is plumbed into that and stuck into this EPDM, and now you have to drain the water. Well, I see an awful lot of old roofing, and after 10 years, the silt in this that collects in this will just block that small bore tubing, and it'll be a problem. And like all expansion joints, as we all know, all expansion joints fail, and because they generally are the first thing to give up. There are other methods, and I apologize for the distortion on this image. Didn't look like that when I put it in. The other methods are pre-manufactured PVC extrusions that can go into this. They weld to a PVC roof. They are tied into other roofing systems. And basically they operate on the principle of keeping the water out. So not allowing the water in the first place is the best way to not have to deal with the water. They're welded, they're continuous, they're compatible with the roofing system, and something like this would be for most people would be a better solution. They're not as pretty, I admit, they're not as pretty. Other things that I see a lot, I deal with a lot of roofing where there's a planter. And where there's a planter and there's a roof, there often is some confusion about how to waterproof this. They'll often choose two different roofing systems. They'll often try and tie the two different roofing systems together underneath that wall and build that planter wall off of the waterproofing. I would strongly recommend against this. If you don't want to see waterproofing, then put a coping stone over the waterproofing on the planter, so you get to the aesthetic finish that you require. On the left-hand side, take the roofing up that wall to the height of the paver or beyond if you can, with or without a counterflashing. This is just a principle sketch, it's not really a truly detailed sketch. And in the planter, often there needs to be slope to drain. And because if you don't slope a planter to drain, you'll kill the plants within it. It'll just sit in water. So that's a great way to do it. And as a principle, I would recommend that you follow this if your aesthetic will allow. This is another one that I get. I do an awful lot of single ply roofing, and a lot of people want to take the single ply up and over the parapet wall and then put the coping cap on it. which is perfectly valid, a good way to do things. But there's no self-healing property in a single-ply roofing membrane. So if you put a screw through it, it won't be sealed. You need to squirt sealant on that screw hole to make it sealed. And you also have to address its interface with a different material. That could be a spray-on air barrier. In this example, it's a peel and stick SPS modified high temperature self-adhered membrane. Most single pliers don't like to be directly in contact with bitumen. So you would need to, in this case, put aluminum tape over all of the cut edges so there's no exposed bitumen between the single ply and the self-adhered membrane. The other way to do this is actually terminate. I've actually turned the parapet wall completely around. You're now looking from within the building out. Take the single ply membrane up the wall, terminate it with the turn bar, cover it with aluminum tape, and then bring the SBS onto the aluminum tape. That way we've got complete chemical separation. And the SBS underneath the coping does provide you with a slightly more protection, particularly around any penetrations with screw holes, because there is a self-healing capacity with an SBS membrane on this wall. And that ends the second part of my presentation. And I now have a chance, if I don't mute myself, to have a look at the chat and see